It is here 10:30 a.m. On the East Coast. It is now time for our next speaker, and this is Anders. And Anders Knutzer is going to talk about boosting your financial planning with automatic forecasting. I would say the floor is yours. Go ahead.
It's off. So I would like to talk to you about boosting your financial planning with automatic forecasting. I have done a couple of implementation of this, and I will walk you through some of the things that I have come across in this process. So, and I'm working with Cognitech and IBM partner in Denmark. So in this presentation, I will talk to you about planning models and some of the simple versus the more complex, and what to choose when. So, and also what part of the organization you would like to put into your model, and then the forecasting on top of that. And not too many formulas, but still some somewhat applied mathy maybe. So in preparing this talk, I was about I didn't quite know how to level what to put in. So this, what you will see in the next slides, is what I've come across and what's just on top of my mind. So when we are talking about these planning models, it can be budgets, forecasts, or something like that. And often you need to have some historic data to be used in the predicting of the next periods. It can be simple models, like you take the past years of data and just put it in to the next year, or you can have some kind of last year plus 5% or whatever. It's quite easy to understand, usable, and very friendly for the users, but not always a very good way of forecasting. And if you want to predict and what is going to happen, maybe that's not the best thing to use, just to use the historical data in that way. So you could use something else, and maybe a little more complex, still using the past historic data, and maybe it's a better way of forecasting, but not necessary. We have just heard about Ukraine, but it could also be COVID or whatever that is happening, and you are not in any way able to predict that what is going to happen in these macro events. So you can argue that going into this much more detailed level, is it even necessary when you can't say what's going to happen? But still, you can also expect in more normal situations that you will have a more neat way of using your past data as a proxy for what's going to happen. But still, you may sacrifice some involvement or ownership from your users when you are going this down this road, because it's much more complex what you are going to implement. So it can be difficult for your users or to know what is going on, and it can easily turn into some kind of black box solution. So in trying to choose the right model for you, I think it's very important to first of all understand the business situations that you're in. So I'm in consulting, so understanding your customer needs is essential. So find the key users that knows how the process is going to be, and knowing what is the industry like in or this special company, what is used, and then for many situations the system landscape can be quite complex. So getting to know that in a bit more detail, and know what kind of data is available and how to get it is also important. And then in some situations you can rely on just using the past history and put it directly into the next periods. And in other cases you might need to have some more fancier math. So it's not you just my point is that you just don't need to take in a lot of math just to show that you can use it, but hopefully only if it's going to be beneficial to your use case. And then last but not least, the implementation of what you are going to do. If you are introducing a very complex model, then you should also be able to sell that into the key stakeholders and to convince them that it is the right way going forward, and maybe they can also be some kind of exponents to the organization in broader terms, because when you're doing these kinds of implementations, it's not for the smaller companies. It's often for the larger ones. So you have multiple stakeholders, multiple input users, and so on. So this is also a very good thing to be aware of, that it's not just a technical installation, it's also an implementation that you have to get over before you are creating any value. So this historical data can be used for forecasting, and I have been doing this together with some of my colleagues at Nukisu-Fit, which is a Greenlandic utility company, and in their case, we did based on the business area that they worked in. We did or the segment of the company. We tried to do the rolling forecast differently. So for the primary revenue, we used some ARIMA modeling with the external variables taking care of weather and population and so on. Of course, we don't know what the weather would be like for the next 12 months, but still you can use the past data and see how did the weather impact the historical data, and then for the next periods you can use some kind of climate normal and see in that sense you can do some kind of sensitivity analysis to see what are the ups and downsides on changes in whether regard to primary revenue. And then for other parts of the company, we didn't go that advanced. We also used this kind of last year, or last year as a fact multiplied with a factor, or something like that. So in the primary revenue, it made sense to use a more advanced model, but in other areas maybe not that much. And also because we needed the stakeholders to be very keen on and it should always be their budget, not some kind of machine that overrules everything. So and then with the variable costs, we made this historical correlation between price and oil price, quantity and oil prices, and could see what are the variable costs that are related to the primary revenue. And with the other areas, we did also use some very specific data entries from for instance the HR module, where we specified or let the user specify what are the next what are the next vacant positions and so on, so to be able to handle some of these factors. But all this is only meant as a baseline for the forecast period, and it's always the users view that is needed to be able to and that is the things that you really need to take care of, that it is the user that needs to be see this forecast as their own product. So in another use case, we also did it. Now some of this is in Danish, but this is mushrooms for the last many years in a large retail organization. So they are selling a lot of mushrooms, among other things. And in this case, we also did some ARIMA modeling, and you can see what are the model that is used for this, and what are the quality measures underlying it. So when you're doing this, you do the forecast on an aggregated level, and then you decompose it to an SKU level, based on the historical data that what has actually been sold on an SKU level, but the actual forecast is done on a higher level to remove some of the outliers that you can encounter if you do it on a very low level. So this is done using a forecast package in R that complement TM1, which these or planning analytics, which these solution has been done in. So I think that's a very good way to increase what you can do with your planning solution to use these open source libraries. So this is what's happening. You have some planning data that you are pulling out of the system, and then you have an R script that handle this model fitting, and then you are processing the data back into your planning solution. And in this way, we have both some standard ETL processing that is handling this data transformation, and also the R code that is responsible for doing this this modeling. So what you can expect from this is it's depending on what are the input data. If you're lucky, this is what you can see, but what you are trying to do is to decompose this time series and into the different signals that you can see in the time series, but it all depends on what the history is like. In some cases, you can see very clear results, and in others, it may be more difficult to see if this is really the actual forecast that will be implemented. But in these very big solutions, you're not always able to see all the data coming through, because you have lots of time series that you are going to process. So if it's possible, it's good to have some kind of automated way to do it, and to be able to handle the outliers and missing data and all that comes in this real world scenario. In this concrete example, I also tried to, instead of telling the R script what kind of seasonality this data is coming from, I tried to use some Fourier terms to handle this part, and then you can see in what frequencies the data is responding in, and then you can clean the data in that way, in a very easy way. Still, it involves a lot of math, but you don't actually need to understand that. You just need to rely on the engine that is running the process. But if you want to go deep dive into this Fourier series, then I can definitely recommend Stephen Brunton. He has a really good series on how to do and what is actually done. It can look a little intimidating with all these formulas, but I think he's really good at telling what is actually going on. And now I think I have been talking for nearly 20 minutes, but if it's okay with you, I can carry on, because I have a couple of more slides that I can present. But I am also welcome to, you're also welcome to come any questions that you might have.
I don't know. I have only one question so far for you, Bruce, but I think we can continue because it's not the question is not relevant to what you've been presenting so far. So we can wait until you finish the slides. Takes a few extra minutes.
Okay. Because what I also would like to share is how you can speed up the calculations, because when you are doing these kind of very large number of data series where you are calculating a lot of things, then it might take quite a long time to finish the forecasting for all these time series. So if you are able to utilize some kind of GPU, parallelize the computations, then it's actually much faster done. And in this example here, I have shown what you can do if you want to. Sorry.
Yeah, hi, this is Alok here. Is it okay to ask a question at this moment? Or...
Yes, of course.
Sure. Okay. Now, this is Alok from India. Right.
Hello.
So, yeah, this is Alok Kumar from India. And yeah,
go ahead,
hi.
ask the question.
Yeah, so my question is that how do you arrive at the estimated quantities of resources that would be required for a specific forecasting application? For example, if you have 1,000 SKUs for 20 locations, right? And you have historical data for, say, for example, 5 days, and your time horizon is daily. Okay. So that means 365 into 5 into 20 into 1,000 records on which you will train your data. So how do I arrive at the resources, CPU resources that I'm going to consume?
I'm not maybe I'm not the right person to talk to you about that, but what I can say is that what I have been doing is to, when I see this problem that I have been solving here with I think it involves about maybe 5,000 time series or something like that, with weekly data going from 2013 to up to now.
So that we can extrapolate, that I understand, but my question was specific to that slide where you were currently, not
Yeah.
this slide.
Okay.
You
yeah.
go back to the slide where you were originally.
Yeah.
Not this. Yes, this one. Yeah. Now you are saying that you will probably need a GPU instead of CPU for parallelization of the process, analytical processing that will go on the top of this.
Yeah.
But my question is always, see, when I go to a customer, right, so then I'm presenting that, okay, I will this, we will do it for you. Then they will, if they like the solution, right, so all maths and everything is fine, but they come very quickly onto the financial or commercial aspect of the solution, right? So if I don't know if I need a Ferrari or I need a Jeep, right, to travel from one place to the other, then I'm not able to onboard the customer.
Yeah. I'm not sure if I understand totally what you are aiming for, but what I'm trying to do here is to show the difference between parallelize on the from a CPU angle to the GPU, and that's why when you are I can hear myself now. But maybe I'm still here. No. So when I'm doing this, I can speed the process dramatically. And
what is the server capacity on which you are running, right? Whether it is a 1-core machine, 2-core machine, or 16-core machine, right?
Yes,
everything will cost other. And then that will also affect the licensing cost if it is based on PVU licensing, for example.
Yes,
right? So that is my worry.
yeah, the good thing about this open source is that when you're using, for instance, PyTorch, like I'm using here, then there's no licensing. So if you have your GPU, then you can use it without any costs, and then you can export your data from your planning solution, and then do the calculations on whatever machine that is available, and then export the data back into your planning solution. And in this way, you are able to dramatically upscale the performance of your application. So I really think that it's a good way going forward, because what I have shown here is that you can in this example it's inverting a 10,000 by 10,000 matrix in less than 1 second. And if you're doing it on a CPU, if it would be on my local machine, it would actually take longer than this 90 seconds. So it's really much faster. The trouble is how to parallelize your computations so that it's possible to utilize your GPU, because the computations that you are going to do, they are in a different form. So that's the main concern in going this way. And normally you would use some kind of classical time series models like exponential smoothing or ARIMA, but I'm not aware of a good way to parallelize them to be able to use a GPU for that. So instead you could use for instance PyTorch to estimate with the stochastic gradient descent, and I found this tutorial on PyTorch home site, where they show a very neat example on how to do forecasting based on a neural network architecture instead, and maybe it's a bit trickier to train that, but on the other hand, it's very easy to use the GPU resources that you have, and in that way you can optimize the performance of your planning application.
Artificial intelligence,
data, analytics,
user group.
AIDAUG.
Join AIDAUG today.